All right, let's talk about using and working with a scatter plot and a supplied line of best fit. We also have a table, and then we'll introduce this idea of interpolation and extrapolation as it kind of refers to this example here. But here's the problem. It says the following table shows retail sales in drugstores in billions of dollars in the U.S. for years since 1995. Let Y be the retail sales in billions of dollars in X years since 1995. A linear model for the data is Y equals 9.44x plus 84.182. So this equation right here is the equation for this line of best fit. And we want to use that model. If they give you this, you don't have to write your own, but if they give you this, we want to use the equation to kind of try and answer the questions below. But before we do that, let's just take a look at and kind of get an idea of what's going on here. So it says the retail sales for drugstores in billions of dollars. That's what our Y is going to represent. That's what we see on the graph down here. That's also what we see over here in the table. But this is kind of money, and we do need to understand that it is in billions. Okay, so when they say 100, that actually means 100 billion. Now, the tricky part here, the X's are years 0 to 15, but what's this 1995 thing? So it doesn't like match up. But this is what we call kind of a zero reference. They're saying, all right, 1995, just let that be 0. That's the start of where this graph is. And then from there, as the X goes up, so does the actual year. So year 0 is 1995. Year 3 would be 3 years after that, or 1998. And then 6 years after that, after 1995 is 2001. So that's kind of how that's working. We reference everything back to 1995, and that's the 0 then for the x-axis. And this x-axis does stand for years since 1995. Okay, so knowing just what the X means and what the Y means is huge for any story problem where there's a kind of a supplied equation. Just figuring out what the variables mean, okay, or at least what they stand for. You don't even need to know what retail sales are. You just need to know that, hey, the Y is the money and the X is the years. And what we're going to find out is we're probably going to know one of them, a year, find the money, or we'll know the money and find the year. All right, so here's the first question. It says, use the scatter plot above to decide whether the line of best fit fits the data well. And I would say yes, this is a good fit for this data. The line is going through the middle of the data points. There's equidistant on either side. It looks good. It's a good fit. So we can kind of just say, yep, that one's good to go. Hey, now we can use this equation to answer the questions below. So for part B, it says to the nearest billion. So that means find a Y, dollars here. Estimate the retail sales in the U.S. in 2013. All right. So in 2013, well, we're not going to plug that in. We know this is a year. Okay. Again, that's an X. So this is going to be X is equal to something, but it's not 2013. Okay, it's how many years is it since 1995? So if we take 2013 and we minus the 0 year out of there, if we do some borrowing, 5 years gets us to 2000, 13 more gets us to 18 years, which means X here is going to be 18. And we can see that that's off our graph. That's beyond where we have data for. And that's what we like to use these scatter plots and lines of best fit for, is making predictions about what's going to happen in the future. We have data up to year 15, but we want to know what's maybe going to happen in 18. So we can make a prediction. We can start planning for the future. And that's what we call extrapolation. We're going extra. We're going beyond what we have data set for. Okay. So extrapolation just refers to that idea of using these lines of best fit to make predictions about what's happening beyond what we already know happened. Okay, interpolation would be to working, something here. What happens by year 2 or year 7? Things we don't actually have data for. Okay, but we would like to know, what the predicted model would show. Okay, so here we go. X equals 18. What we figured out here for the year 2013. So we're just going to go ahead and directly substitute that. So for question B here, we take our line of best fit, and we're going to evaluate or simplify this equation for when X is equal to 18, because that's good. That's what corresponds to that 2013. So we'll get 9.44 times that by 18, and then add the 84.182. And here's what we end up with here. If we grab our calculator and type, do the multiplying first, excuse me, that gives me about to 169.92. And then add up our values here, and we'll get Y equals 250.1. 254.102. And then know that, remember, this is in billions and it is in dollars. So there's our answer for the first one, 254.102. The answer blank already down here says billions of dollars, so I don't need to include the labels. But that's where and it kind of makes sense. You can see the increase is going up here by about that much. That's a reasonable answer. All right, the last one, question C, it says use the equation to find the year. So now we want to find an X in which the retail sales will be 240 billion. So that's less than 18. Okay, we can see that, but more than 50. So hopefully our answer falls in there somewhere. But then again, they want the year. So now we don't want to give the X value. We want to give the year here. But for question C, let's go ahead and see if we can't figure this one out. Again, this time Y is going to be equal to 240. And it's in terms of billions already, so we don't need to do anything. But we're going to plug 240 in for our Y. So plug 240 in for Y. That's then 9.44x plus the 84.182. And again, it's the idea of they're going to give you X, find the Y, or they're going to give you Y in this one and find the X. So this one we do need to do some solving. So let's minus the 84.812 from both sides. That's going to give me 155.818. is then equal to 9.44x. Okay, and then I'm going to divide both sides by 9.44, and that should get me x to be approximately 16.506. Okay, and we said it should be somewhere between 15 and 18 based upon kind of what we already have information for. Okay, now the question that needs to be answered here is what year? All right. So what year does year 16.506 refer to? Well, it's 16 years later, 16 and a half years later. So in this case, since 1995, that's 0. So 1995 plus the 16, if we just take 1995, add 16 years to it, that's going to get me into, carry the 1, 2011 is where we would find that this thing's going to fall. And technically it's 2011.5, but that's still 2011. It's just halfway through it. It won't be 2012 till we get to a whole nother year there. So it's kind of almost a round down scenario. But there you go. That's it for now.